Okay, so look at yours. It should look like this. So we'll do this first one together, and then we'll see if you can do the next one. So we've got domain. Now, when you do domain, did you do this little squiggly? Right, remember that bracket? And it doesn't have to be perfect. It's as best as you can. So our domain is the first numbers in each. It's the X numbers. If they're all the same, all you have to write down is 3. That's it. So then in the range, switch colors here. The range is going to be the second numbers. But remember, you have to put them in order from smallest to biggest. And if they repeat, only write it once. They don't, so we don't have to worry about that. 0 is the smallest one. Then 1. Then 2. Okay, and that's it. That's your domain and range. That's what we talked about on last Thursday, which was like 4 days ago. So it's been a while.
Wow.
Yeah. Okay, so here's the next one. So again, you're doing domain and range. Domain. It just looks different how I gave you the numbers. Okay, and I'm really just looking at your domain and your range. So you can write the table, the chart if you want, but you don't have to. Here, do you want to sit in Dylan's seat with it? So just to give you an idea of where we're going, today we're working on domain and range for the warm-up, but we're also going to hit that, is it a function, yes or no? So that's the next page of the notes. We're going to try to get through pages 4 and 7 of the notebook for our classwork. Tomorrow we're going to keep practicing domain and range because we're going to learn something a little bit new towards the end of class. And then we're going to have our standard check, our first standard check on Thursday of this week. So just gives you an idea of where we are and where we're going for this week. Okay. Give me your domain. What do you think? Go ahead, Abby. Go for it. -5, comma.
-3.
Yep. 0. 1. 5.
In order.
They were already in order, right?
Yep.
Lucky us. So basically, she just wrote down the numbers in the X row, right? Because they were already in order. When you go to the Y's, though, are the Y's in order? No. And there's a number twice, right? So there's a 2 here and a 2 here. So you're going to write it 2 times? Nope. You just write it once. Okay? So list them out for me, smallest to largest. Got them already? Go ahead.
-1.
Okay. 2. Okay.
3.
Okay. There you go. With a fancy little bracket
Wow.
on the end.
I like it.
Okay. So the last one that we're going to do is a mapping diagram. Okay. So we did a set of points. We did a table. So the next one you're going to see is a mapping diagram. So that's what this looks like. So we saw one of those last week. Again, we're just doing domain and range. Listing them out with our curly little brackets. This one should be super quick. Because in a mapping diagram, that is the best way to find domain and range because it already follows the rules for you. It's already in order, and it's not written twice. Yep. Okay. Celestine, what did you list out for your domain? Perfect. See how nice that is for a mapping diagram? The ones on the left are going to be your X's. That's going to be your domain. So you just list out these ones here on the left. 3, 5, and 9. That's it. Okay. And what about the range? Zach, what did you have for range?
-1,
0, 2.
Yeah.
There you go. Okay, so that was practice. Just a reminder of what we were doing before we left. Let's flip in our notebook. So when you put this in to your binder, put it right in on top, yeah? Okay, because we're going to flip this open and do this piece of paper every day right at the beginning. So put that in the front. Okay? And then in your blue packet, you're going to page 3. And at the top of page 3, it's our first white piece of paper. It just says function. Okay, this is... Yes, ma'am. So this is super zoom here. I gotta zoom out so you can see this a little bit. Here we go. Okay, so last Thursday we said a relation was a set of points. Okay? So we're going to look at a set of points and we're going to say, is that set of points a function or not? How are we going to know? So a function is a relation, which, since it's been a while, I'm going to put in parentheses what a relation is. A relation is a set of points. We already have that somewhere. But just in case. So a function is a relation or a set of points where every x goes to only one y. Okay, we kind of talked about that last week when we said, okay, when we put something into our function, right? So what am I allowed to put into the pencil sharpener? Right? Pencils only, right? So when we put that pencil into the pencil sharpener, what comes out? Okay, so if I put a pencil into my pencil sharpener and marker comes out the other side, that's confusing, right? Only pencil shavings come out. So what we have to do is the function, when we put something into it, it has to know what to kick out. So if two things kick out, it's no longer a function. So what I mean by that is, if you had, for example, here's an example of a non-function, and then I'll give you an example of a function. So this is my non-example. So this does not work. If I had the point 2, 5, that means when I put 2 into my function, the function knows to spit out 5. But if I also had the point 2, comma, -1, now I have confused my function. And now it's error, right? Because when I put in 2, it says, what do I do? Do I spit out a 5 or do I spit out a -1? I don't know what to do. So it's not a function. A function can only spit out one number. It can't spit out 2 different numbers. It's confused. Okay, so right here, if you have a 2 and a 5 and a 2 and a -1, that's not a function because it's not spitting out just one number. It's trying to spit out 2. So my example would be, if I have 2, 5, then the next point cannot be a 2. Anything else. So we'll pick out 0, -1. That would be a function. It's okay. 2 just goes to 5. Doesn't go anywhere else. 0 just goes to -1. Each x value is paired up with one y value. Here, the x value of 2 was paired up with 5, and it was paired up to -1. Can't do that. Okay? So that's how you're going to tell if I give you points. Okay, so if I give you points, and you see 2 going with 5 and 2 going with -1, can't have that. How are you going to tell if you're looking at a graph? Okay, so what you're going to do on a graph is you're going to look at all of these x values down here. So we have 1, 2, 3, 4, 5, 6, and you're going to see, are there 2 dots on that x line? So here we go. We're going to come up here. At 0, there's no dots, okay? At 1, there's a dot, but there's only 1. At 2, what happens? I hit this dot here, and I hit this dot here. When you hit 2 dots, that means you had 2 points. The first point was 2, 2, and the second point was 2, 3, 4, 5. 2, 5. Do you see how 2 was paired up with 5, but 2 is also paired up with 2? So is that going to be a function? No. So what that's called is it's called the vertical line test. So how do you tell if it's a function? What we're going to do is we are going to use the vertical, and we now know vertical is up and down, right? We put that on our notes. So we use the up and down vertical line test. Okay, I'm going to put something else right behind there so we know for sure, like, how do we use that test, okay? But that's what we're going to use. So right here, this first one that we did, it says, does it pass the vertical line test, the VLT, vertical line test? Does it pass that vertical line test? Well, we said no, because this was the point 2, 2, and this was the point 2, 5. So 2 went with 2 different y values, which is not okay in a function. So does this one pass the vertical line test? No. Because x equals 2, so on that line where x was 2, okay, x equals 2, has 2 y values. Okay, it had 2. What if it had 3 dots? Well, you would say it's got 3 values. Now, there also is a failure of the vertical line test right here at 5. So you could also say x equals 5, there's 2 y values as well. Okay? So, right behind here, I said use the vertical line test. How do I use the vertical line test? Okay? So, when you're looking at the vertical line test, what you're looking for is every vertical line has only 1 dot. Okay, that's what you're looking for. So when you do that vertical line, you're looking for there only to be 1 dot on that vertical line. If there's 2 dots on that vertical line, you have to say, nope, that doesn't work. Okay, so we're going to slide to the next example. And we're going to see if that one passes the vertical line test. Then we're going to slide to this next example, see if that one passes the vertical line test, etc. Okay? So what you're doing is at every one of those x values, so you can start at 0 if you want. So how many times am I going to hit this function? Okay? So I'm going to zoom in on this one. So sorry if you didn't get that written. I can zoom out in just a minute. But I'm going to zoom in so we can see this a little bit better. Okay, so what I'm doing is I'm making a imaginary vertical line here. How many times does this vertical line hit that relation? 1 time. Let's go to this next one. How many times do I hit it here? Just 1 time. How many times do I hit it here? Just 1 time. Is there ever going to be a line where I hit it twice? No. So this is good. We're good to go. So does this pass the vertical line test? Yes. And if it passes the vertical line test, you get to call this relation a function. Okay, so that relation is now a function. It is, and what happens is, why do we care? Functions have special things about them. Okay, so if I have a function, then I get to do special things, which is what we're going to do at the end of the week and moving forward. We're going to work with functions only. Okay, let's look at this next one. I'm going to slide that over. Does this one pass the vertical line test? Yeah, so we're looking through. I only hit one. Go over the next one. Only hit one. One. Is there anywhere on there where you hit 2 dots when you're making those vertical lines? No. So does this one pass the vertical line test? Yes. So I wanted you to see 2 examples there. One, I have this straight line, and that one passed the vertical line test. Here I had just a bunch of dots, and that one passed the vertical line test. So it could look like this, or it could look like this. It doesn't have to look any way special. Also, you could have something that looked like this. It could look crazy and still pass the vertical line test and be a function. Okay? So just you know that kind of for the future. Now, going over to the last one. So this is also a function. Okay, does this one pass the vertical line test? No. No way. So even at this first one, I can kind of come to this first line here. I hit it here and here. So you can pick like the x value of 1, 2, 3, 4, 5. All of those x values have multiple y values. So does it pass the vertical line test? No. At x equals 1, there are 2 y values. Okay? And if you're not sure where I got that, I want to point that out again. Where did I get x equals 1? Am I just making that up? Did I text it to you on your phone? No. I got it from right here. Right there. X equals 1. So I got the number x equals 1 from right here. Remember, this is your x-axis. Okay? So it says x equals 1. There are 2 y values. Okay, now we're going to put it all together. So what you see next, it says, I have a picture here. I want you to tell me if that is a relation or a function. Does it actually get to be called a function? And then I want you to give me the domain and range. Okay? Now we've been practicing this relation or function piece, so this should be the easiest part. What do you think? Does it pass the vertical line test? No. It doesn't, not at any single x value does it pass the vertical line test. So right here at 0, there's 2. At 2, there's 2. At 4, there's 2. So if it does not pass the vertical line test, is it a relation or is it a function? It's a relation. So here we've got this relation. And you don't get to say, because it doesn't pass the test. You don't get to say that. Why doesn't it pass the test? Because at x equals, a little cheat for you there, at x equals, and then pick one. Do you want to say at x equals 0? At 2? At 4? Because all 3 of those are failures. So you just pick one. At x equals 0, there are 2 y values. This is one we did not do in warm-up. Okay? Domain, range. Okay, so phones down, eyes up. We're going to talk about this one. How do we do domain and range for a picture? Okay, do you remember this? I'll do it with the pencil so that we can erase if you need to, because sometimes the lines get all sorts of crazy. Okay, I'm going to put this in here. Ready? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. So I have the numbers. Okay, so what x numbers should I write in to my domain? How do I know? Okay, if you can't see them by looking at the picture, then what you do is you go to the dots. Okay, and which way is the x-axis? So I'm looking for my x numbers. So my x-axis, if I'm right here, my x-axis is this line. Okay, so point to that line. That is your first number that you write? 0. Is there anything here that I should point at 1? No, there's no dots here. So go to the next dot. What about this dot up here? I didn't do that dot yet. But if I did this dot, it would also point at 0. So I already have that one. Shouldn't write it twice, so I go to the next one. The next one over, if I use this dot right here, point down to the x-axis, what am I pointing at? 2. That's the next number I write. And then if I did this next dot up here and pointed down, it would point at 2 again. Don't write it twice. Just write it once. Okay, and what's my last number going to be?
4.
Last number is going to be 4. And both of those last dots would point at 4. Okay, so I did that in pencil because if all of the lines kind of confuse you, because we're about to draw more lines, right, to do the y-axis. So if the lines confuse you, you can erase the lines in between doing your domain and range. So if that's confusing to have all those lines there, because now we're going to take all of these dots and we're going to point at the y-axis. So the y-axis is this line. So instead of pointing down, we're going to point over. Okay. You can go in whatever order you want for the points, but remember when you list them out here, they have to go in numerical order. So I like to start at the bottom. And this dot right here, this lowest dot, points at the number 1. So write down a 1. Point over here, 2. There's nothing at 3 to point over to 3. I do have numbers here that would point over to 4. And that one to 5. I kind of like to do all of my arrows and then I just list out the numbers that I'm pointing at. So I have a 1, a 2, a 4, and a 5. So 1, a 2, 4, and a 5. Okay, so we didn't do that graphic one in the warm-up, but now you can kind of see why, because it was going to be here. Okay, so now the other two, so we have to tell function or not function, because that's what we're about to do. You have 8 questions on the back of this piece of paper that you have to say function or not function. We know now how to say function or not function for a graph. What about a table or a mapping? Okay, well, what you're looking for is you are looking for every x to go to just one y. So this x right here goes to one y, right? So this has only one arrow. That only goes to one thing. That's good. Yay. What about the next one? Is this only going to 1? Yep. Yay. What about this one? Is this only going to 1? No, that number, that x value, is going to 2 different y values. That's where it becomes no longer a function, it's just a plain old relation. So is this a function, yes or no? This is no. Why? Because x equals 2 goes to 2 y values. We don't want that. So in the part that says, how do you tell if a table or a mapping is a function? So you're looking for every x to have every x to only have one arrow, okay, coming out of it. Or, we'll talk about the table one in just a minute. So you're looking for every x to only have one arrow coming out. Do I care about the y? No. Y's can be as greedy as they want. Look at this 2 right here and this 1. This 2 right here has 3 arrows coming in saying, gimme, gimme, gimme. Do I care? No, that doesn't matter at all. The only thing that matters is this first bubble, and every one of those numbers in that bubble can only have one arrow. They can only have one place that they're going. 10 only has one place. -8 only has one place. 6, -6, -4, -2. This is a yes. Why? Because every x only goes, there's an L there, only goes to one y. Every x only has one arrow going out of it. I don't care what's going on in the y, because my function is like a brain. So when I tell it what is going in, it just tells me what goes out, just like a calculator. But if the output could either be 2 or 5, would your calculator be able to tell you that? The answer is 2 or 5. No, your calculator gives you one number. So whatever I put in, the calculator spits out one number. So if you're looking for it to spit out 2 different numbers, you no longer have a function. Okay, so that's our mapping diagram. Last little part right here is the table. So in the table, you're looking for every number in the x to only happen one time. If it happens twice, that means it's going to 2 different places. Okay, so 16 goes to -2, but look, there's another 16. So right here, 16 is going to -2, but 16 is also going to +2. That's not okay. So in a table, so every x has only one arrow. That's for the mapping. In a table, you're looking for every x keep forgetting the L in that only. Every x to only show up once. If that x value shows up twice, that means it's going to a separate place. It's going to 2 different places. Okay? So we're looking for it to only show up once, not to show up twice. So this one is going to be a no. There's actually 2 that ruin it on this one. 16 ruins it, and +1 ruins it for the x's. No, why not? Because x equals 16 goes to, and right here you could say, instead of saying goes to 2 y values, you could tell me the y values. So 16 goes to -2 and +2. You could say that. So right here you could say goes to -2 and +2. Or you could just write goes to 2 different y values. However you want to say that is up to you, but that's why. Is that one number is going to 2 different places, and that's not okay. Okay? So the last one you're looking for is that x value going to repeat. Okay, so do you see, here's -3. Do you see another -3? No. Okay, good so far. Here's 0. Do you see another 0? Nope. What about 3? Does that show up again? 6? 9? So this is good. Is this a function? Yes, it is. Because every x goes with only one y. Okay, so you're now about to show me that you know what we just talked about, okay, by turning the page. When you turn the page here, you should have already done the domain and range part. So there should be a blank that says function, ? And that is what you're filling in. So last Thursday, we did page 4, and we filled in all of the domain and the ranges on page 4. So your job now is to fill in the part that says function.
Can you just write yes or no?
And explain. You're going to have to explain on the assessment that we take, so I just want you to write. It's only 8 times. Okay, so the next page, let me show you what that looks like. Let's make sure everybody's on the same page. Page 4 looks like this. And last Thursday, we filled out the domain and the range. So now you're telling me if it's a function or not. Okay, and we'll check that in just a minute. And then the last 5 minutes, I know this is so terrible of me, but the last 5 minutes, we're actually going to keep going on more notes. I know. Okay, so a couple minutes here, and then we'll go right back to notes. Right, so you got the double zeros there. So what about this one? 0? With -3? Is that 0?
So no. Because those X's do not have one Y. This negative 7 goes to 0. This negative 7 goes to 1.
So you just gotta get the shapes.
They do not have one Y. One Y. Each X means one Y. So like this one, this X goes to 2 Y's. So normally, no. But this one is a yes, because each X goes to 1 Y. That's okay. This 3 goes to 4 and 5 goes to 4. That's okay. Those are 2 different X's. Yes, the Y's can be repeated. The X's cannot. Okay, that's the difference. So.
Okay, that pushed us right up to the 45. So go ahead and grab your binders and put them back in their slot.